In this session, we're going to introduce you to Arista's MLAG feature. This session focuses on the terminology of MLAG and a few show commands. We cover a full MLAG configuration walkthrough in another session. MLAG stands for Multi-Chassis Link Aggregation. The concept behind the MLAG feature is that we want to make two switches look like one switch to all devices, which could be other switches, routers, firewalls, load balancers, and hosts. By making two switches look like one to the connecting devices, we achieve active-active forwarding by pushing spanning tree to the background. By active-active forwarding, what we mean is that for a host with two interfaces connecting to two Arista switches, spanning tree would normally block one link so as to prevent a layer 2 loop. While spanning tree is great for preventing loops, the results are a loss of bandwidth capacity and delayed resiliency or failover. But with Arista's MLAG, our two switches look like one. The host can run industry standard LACP, or Link Aggregation Control Protocol, to combine both interfaces to act as a single interface. LACP is also referred to as 802.3 AD. This makes two individual 1 gig interfaces run as 2 gig. 10 gig now becomes 20 gig of active forwarding, or 40 gig now becomes 80 gig of active forwarding. With Arista's MLAG, we no longer have spanning tree blocking one of the links, leaving us with half the possible forwarding capacity between devices. Don't fear, the spanning tree process is still running, and the agent can jump in if we have an MLAG failure. Let's look at a lab switch example. In this lab, I have 4 switches running. Switch 1 and Switch 2 are configured together in an MLAG domain, and Switch 3 and Switch 4 are configured together, making another MLAG domain. Looking at Switch 1, we can issue the command show MLAG. So here on Switch 1, show MLAG. The output lists a couple of sections including our MLAG configuration, status, and any MLAG ports. We can see our MLAG configuration by issuing the command show run section MLAG. The output includes our MLAG VLAN, our PeerLink port channel, our Layer 3 MLAG interface, and at the bottom of the output, we can see our domain ID, the local interface, our peer address, and the PeerLink port channel. So the question arises, how do we take two individual switches and make them look like one to all the devices that connect to them? When two switches are combined into an MLAG domain, they merge and agree on the use of one bridge ID. It is the use of one bridge ID that makes downstream devices think they are connected to a single switch. Since we're combining two switches to look and act as one, we gain layer 2 redundancy, increased bandwidth, and improved availability. MLAG is only configured on the Arista switches. The devices that connect and take advantage of MLAG only need to be configured with the industry standard LACP protocol. The two Arista switches that you combine with MLAG are referred to as MLAG peers. There can only ever be two switches as part of an MLAG domain. These two switches are connected via physical links placed into a port channel and known as the MLAG peer link. In my lab, on switch 1, that is Ethernet 1, Ethernet 2, and port channel 10. So we can look at those configurations with the show run interface Ethernet 1, enter. And you can see it's just a switch port mode trunk and then the association to channel group 10 mode active. The other physical interface in this port channel is interface Ethernet 2, show run interface Ethernet 2, enter. That is also switch port mode trunk and channel group 10. And then finally, show run interface port channel 10, enter. And we can see I'd added a description, MLAG peer link, switch port mode trunk, and then there's a trunk group association, which we'll cover later. It's considered best practice to use two physical links between the MLAG peer switches. These two physical links should be combined into a single port channel. And in the case of using Arista's modular chassis switches, ideally, you'll make these connections via redundant line cards to protect against a single line card failure. The MLAG peer link provides a path between the MLAG peer switches that is used to synchronize the MAC address table of the two switches in the MLAG domain. And it is the transport for the MLAG UDP and TCP associations between the switches for the MLAG Keep Alive mechanism. This MLAG peer link also carries production network traffic between the MLAG peers if or when you have devices that are connected to only one of the two switches in the MLAG domain. Ideally, all devices should be dual-homed with at least one connection to each of the MLAG peers, allowing them to take full advantage of the bandwidth and redundancy benefits. Let's go through some MLAG terminology. MLAG domain. That's a pair of two Arista switches. And as an example, in my lab, that's switch 1 and switch 2. MLAG peer. A single switch within an MLAG domain. MLAG peer link. A non-proprietary, standard Ethernet link between MLAG peers to synchronize state between the MLAG peers. The MLAG peer link is a standard layer 2 trunk that carries all VLANs by default. MLAG member port is one or more physical ports connecting to other devices, such as switches, routers, firewalls, load balancers, and servers. The MLAG VLAN is a specific VLAN used between the MLAG peers on the MLAG peer link for communication between them. In my lab, I'm using the common Arista example of VLAN 4094 as the MLAG VLAN and the layer 3 interface. So you can see that here in the output of our show MLAG, the local interface is VLAN 4094 and the peer address, that 172.16.11.2, is assigned to interface VLAN 4094 on switch 2. While this switch has, if we take a look at show run interface VLAN 4094, you'll see it has the IP address of 172.16.11.1. With Arista's MLAG, there are two active control planes and two active management planes. Each of the two switches in an MLAG domain have their own active control plane for features such as OSPF, BGP, multicast, and others. Each of the two switches in an MLAG domain have their own management plane for configuration management. So you SSH into each member of the MLAG domain individually, and you configure them individually. Both switches of the MLAG domain have their own configuration files. So currently, we're logged into switch 1. Let's SSH over into switch 2 of my lab. So if we exit here, we'll up arrow, and now we're on switch 2, where we can also issue the show MLAG command. And we see our MLAG domain ID matches switch 1, which is MLAG 01. Our local interface, the peer IP, we see our MLAG status and our MLAG member ports. And we can issue the command show run section MLAG and hit enter. And we'll see our VLAN 4094, our MLAG peer link port channel. Port channel 34 is an MLAG member port, so that goes down to switches 3 and 4. We have an interface VLAN 4094 with the associated IP address, and then the specific MLAG configuration of our domain ID, our local interface, the peer address, and the peer link. As a summary, Arista's MLAG solution provides us with the ability to take two switches and make them look like one to achieve better bandwidth utilization and offer a level of network resiliency for all devices connecting to the MLAG domain. The connecting devices simply run their industry standard implementation of LACP.